Hey students, we're going to go over your answers to acceleration problems. But first I wanted to make sure that you review this as a reference. Okay, these are the types of forces and their symbols, okay, on this side, because we'll be using those symbols as we go through the activity today. And also relevant information that you need is how to solve for weight, which is mass times the force of gravity acting on an object. And for simplicity, we are going to use that acceleration due to gravity as 10 meters per second squared in all of our examples, okay? Keep in mind, this is Newton's second law of motion. That's how we get this formula. It can be rewritten, Newton's second law of motion, to solve for weight if we know the acceleration due to gravity, which is 10 meters per second squared, and the mass of the object. Okay, so this is just coming off of Newton's second law. If you're in my A-Day class, your quiz is on Thursday, the 9th. If you're in my B-Day class, your quiz is on Friday, the 10th. All right, so we did these in class. We did the bag, we did the truck, the car, and the elevator. Some students didn't get to this one, so I'm going to review that, and then we're going to go into the paper that I gave you to work for practice. So it's important to read the scenario. It gives you an understanding of what's happening before we answer the question. So we have a skier that is 65 kilograms sliding to the right across flat snow. So here is the force diagram that shows what's happening. Remember, FF is friction. This is a contact force of two objects sliding past each other. So there is a frictional force pushing back on the skier toward the left. Obviously, they're on flat surface, flat snow. W stands for weight, and N stands for normal. This is the contact force of an object's weight being supported by another object. And those are balanced, these two forces. This is not balanced. There's no opposing arrow in this direction. So the mass of the skier is 65 kilograms, and his weight is written right over here. His weight is 650 newtons. And I'm going to write the force of gravity is the same thing as weight, 650 newtons. What is the net force on this object? So he's moving to the right, and there is a net force of 65 newtons to the left. Is the object accelerating? Yes, because there are unbalanced forces. And remember, unbalanced forces cause acceleration. What is the rate of acceleration? This is where we want to use Newton's second law of motion, and to determine what that will be, we have to look at our triangle here. So we're solving for acceleration, which is force divided by mass. And it's the net force divided by the mass. In this case, our net force is 65 newtons left, and the mass of the skier is 65 kilograms. Which will be 1 meter per second squared left. So remember, the skier is moving to the right, and there's an unbalanced force acting on him toward the left. So that is going to slow him down. He is slowing down. He will eventually stop because of the unbalanced force acting on him of friction. Okay, let's go over your answers and check your work as we go. If you didn't get it, please use a different colored pen or pencil to write in the answers. I will be collecting this. And so you're going to turn this in on your next class. So if you didn't complete it entirely, please use a different pen or pencil so that I can glance at that and see what you were having trouble with. So we have a 10-kilogram cat falling through the air with a 60 Newton of air resistance. So we're going to draw the free body diagram. We have the cat falling through the air, and we have air resistance pushing back up. The air resistance we're going to write as FD. So if you look back at your symbols, air resistance or drag is FD. So FD is 60 newtons. And we need to know the force of the cat. We know his mass, but we need to find his weight. Remember, weight, which is the force of gravity, is equal to the mass of the object times the acceleration due to gravity, which is a constant rate. And for purposes of today's activity, we're going to round that to a whole number of 10 meters per second squared. So we just plug in his mass, 10 kilograms, times 10 meters per second squared, and his weight is 100 newtons. So is this object accelerating? Yes. Unbalanced forces cause acceleration. We have a net force of 40 newtons. So our net force we get from subtracting opposite arrows. So because these arrows are in different directions, you subtract 100 minus 60, and you get 40 newtons down. So because he's falling down and the unbalanced force is in the same direction, he's accelerating, he's speeding up, okay? So he's going to be speeding up. What is that rate? Well, remember, acceleration is equal to the net force divided by the mass of the cat. Our net force is 40 newtons down, and his mass is 10 kilograms. So 40 over 10 is 4, and our unit for acceleration is meters per second squared down. Okay, remember, acceleration is a change in velocity over time, and it's always a vector component, so we have to have a direction with our acceleration. Number 3, a 3-kilogram book sliding across the table to the left with a 5 Newton frictional force. All right, so we've got a book that's moving to the left, but before we draw that, let's draw the weight of the book and the normal force acting on the book. And we know that those are going to be balanced forces, the up and down, because the book isn't moving above the table or sinking into the table. So these two forces are balanced. So in order to find the weight of the book, you need to take the mass of the book times acceleration due to gravity. So our mass of a book is 3 kilograms times acceleration due to gravity, 10 meters per second squared, which is 30 newtons. So our weight is 30 newtons, and our normal force is also 30 newtons. Those are balanced. But the book is sliding to the left, and there's an opposing frictional force of 5 newtons to the right. So we're going to draw an arrow and label that 5 newtons. And that is the frictional force. So yes, the object is accelerating because we have an unbalanced force to the right. Unbalanced forces cause acceleration. Well, the book is moving to the left, and so is it going to be traveling at the same speed? Well, we just answered it here. It's not. It's changing its speed. And remember, under the umbrella of acceleration, an object can either speed up, slow down, or turn. So in this case, the book is going to start to slow down because it's moving to the left, and the unbalanced net force is 5 to the right. So to find the acceleration, we take the net force divided by the mass of the book. So 5 newtons right divided by the mass of the book, which is 3 kilograms. That's going to give us a number. We'll just round it to the tenths place, 1.7 meters per second squared right. So the book is slowing down. The overall net force is to the right, which is the frictional force. The overall frictional force is a net force of 5 newtons to the right. The book is moving to the left. It's going to slow down and eventually stop. All right, next question is about a boat. A 800 kilogram boat with an engine thrust of 700 newtons, moving at 30 meters per hour through the water to the right. So the first thing we want to find is the weight of the boat. We have the mass of the boat. We know that weight, which is the force of gravity, is equal to the mass of the object times acceleration due to gravity, which we're going to round to 10 meters per second squared. So the mass of the boat is 800 kilograms, and we're going to multiply that by 10 meters per second squared. So the weight of the boat is 8,000 newtons. So we have balanced forces. The weight of the boat, which is the weight, the force pushing the boat down, is 8,000 newtons, which is balanced with a normal force of 8,000 newtons. So those are balanced, but the boat is moving to the right, and it's going at 30 miles per hour with an overall thrust of 700 newtons. So going back to your symbols, the force created due to an engine, like a jet engine or even a boat engine, is Ft, which is for the force of thrust. So we're going to write that here, and it's 700 newtons. So right away, you can see we have unbalanced forces acting to the right. The boat is definitely accelerating because unbalanced forces cause acceleration. Remember, it could be speeding up, slowing down, or turning. Well, the boat is already going to the right, and it's adding more force as it's moving to the right. So the rate of acceleration is the net force divided by the mass of the boat, which is 800 kilograms. So we're going to substitute our net force, which is 700 newtons right, divided by the mass of the boat, which is 800 kilograms. We're going to round it to the tenths place. It's almost 1, but we'll 0.9 meters per second squared right. The motion's to the right, as is the net force, so he is speeding up. Last problem, a 1,900 Newton motorcycle and rider moving to the right slams on the brakes with a 400 newtons of force. This is the frictional force. So the motorcycle, the weight of the motorcycle is 1,900 newtons. The normal force is also the same because he's not sinking into the ground and he's not floating up in the air. So that's balanced, but he's moving to the right and he slams on his brakes. Remember, that's frictional force. It's the opposite direction of the force that the object's moving. So we've got 400 newtons. That's your frictional force to the left. The object is accelerating. Unbalanced forces are occurring here. You can see it in the diagram. We have an unbalanced force, net force of 400 newtons. Unbalanced forces cause acceleration. So your net force is 400 newtons to the left. Now we need to find the rate of acceleration. Acceleration is your net force divided by mass. Our net force is right here, 400 newtons left. And we're going to divide that by the mass of the motorcycle, which is, we have to find. Okay, we don't have the mass, we have its weight. So remember, using our triangle here, mass is force divided by acceleration due to gravity. So we can use this formula because we're trying to find the weight. We have the weight, we're trying to find the mass. So mass is weight divided by acceleration due to gravity. That is a constant. Gravity's acceleration is 10 meters per second squared. The weight of the bike is 1,900 newtons. So the mass of the bike is 190 kilograms. We're going to use that, plug it in here for the mass of the motorcycle. And rider. Okay, motorcycle and rider. And if you divide that, you're going to get a little over 2. We'll round it to the tenths place. And because it's slammed on its brakes, the unbalanced force is to the left. And the object is slowing down, which is a form of acceleration. This is similar to what your quiz will be like. You will not be asked to draw these force diagrams, but remembering what we did on the first page together as a class sheet and this sheet, make sure you review your work and understand how to read a problem, get information from the problem, how to find weight given mass and the constant acceleration of 10 meters per second squared. You will get these triangles on your paper, but you need to know how to use them. I will also remind you of this number for your acceleration due to gravity. And that is it. So have a good night, and remember to turn this in when I see you next time.